Hello everyone! Welcome to another episode of Deep Dive Knowledge Talk. Data. Hello everyone! To kick off our discussion, could you explain the common challenges faced by large language models, LLMs, and text classification tasks, particularly in relation to their reasoning abilities and limitations with token counts?
Large language models, LLMs, are like very smart robots that can understand and create text, but they have some challenges when it comes to classifying text, which means figuring out what kind of message or emotion it carries. One big challenge they face is that they sometimes struggle with reasoning, which is like solving a puzzle. Some texts can be tricky because they include things like sarcasm or irony, which are like hidden clues that require deep thinking to understand. Imagine trying to guess a riddle. If you don't catch all the subtle hints, you might get it wrong. Another issue is the limited number of tokens, which you can think of as the number of words or pieces of information the robot can hold in its memory at one time. For example, if you have a small backpack that can only carry a few books, you won't be able to bring all your favorite stories with you. In the same way, LLMs can only look at a small part of the entire text to make their decisions. This means they might miss important details that could help them classify the text correctly. To tackle these problems, a new approach was introduced that helps the models gather clues and reason through the text step by step, allowing them to perform better at understanding complex texts.
Could you elaborate on the clue and reasoning prompting CARP framework and its three-step reasoning strategy? How does this approach specifically address the challenges posed by complex linguistic phenomena in text classification?
The clue and reasoning prompting CARP framework is like a treasure map for large language models, LLMs, that guides them step by step to find the right answers in text classification tasks. It uses a three-step reasoning strategy to help the models tackle complex language challenges, which can be as tricky as solving a mystery. 1. Finding superficial clues. The first step is like gathering clues at a crime scene. The model looks for important keywords, tones, and relationships in the text that give hints about the meaning. These clues are the pieces of information that help the model understand what is going on in the text. 2. Inducing diagnostic reasoning. After collecting the clues, the second step is like piecing together those clues to form a story or explanation. The model uses the clues in the text as a foundation to think critically and reason about what the text means. This helps in making sense of tricky language features like sarcasm or contrasts. 3. Determining the final label. In the final step, the model makes its best guess about the classification, which can be like choosing the right answer on a quiz after considering all the clues and reasoning. This means it looks back at everything it has gathered and decided what label, like positive, negative, or neutral, fits best. By breaking down the reasoning process into these clear steps, CARP helps the models become better at understanding complicated language situations. This approach not only makes the reasoning clearer, but also allows the models to work effectively within the limited amount of text they can consider at once, enhancing their performance in classifying text accurately.
How does CARP integrate a fine-tuned model on a supervised dataset for an ENN demonstration search? And what role does this play in enhancing the LLM's performance in text classification tasks?
The CARP framework integrates a fine-tuned model on a supervised dataset for demonstration search in a way that enhances the performance of large language models, LLMs, in text classification tasks. You can think of this integration as hiring a knowledgeable guide who knows the best paths to take based on past experiences. Here's how it works and its importance. 1. Fine-tuning the model. First, a model, like Roberta, is specially trained on a dataset designed for the specific task. This is like giving the guide training in the area they will be leading you through, because the model is fine-tuned with specific labels related to the task. It becomes very good at understanding what useful examples look like. 2. Demonstration search. Next, this fine-tuned model is used to find similar examples, like a person finding similar stories in a library, through a method called hang in, nearest neighbors. It takes the input text and searches for examples in its memory that are closely related to it. This ensures that the examples retrieved are relevant to the specific classification task at hand. 3. Connecting the dots. By using this fine-tuned model to gather nearby examples, CARP effectively bridges the gap between the LM and a wider range of training data. Even though the LM can only consider a small amount of text at a time, the fine-tuned model helps it access a broader base of knowledge. This allows the LM to utilize not only its general understanding of language, but also task-specific insights from the training set. In summary, by combining a fine-tuned model with the LM, CARP significantly boosts the LM's ability to classify text correctly, especially in situations where there is limited training data available. This approach shows remarkable performance improvements in various benchmarks, demonstrating its efficiency in real-world scenarios where data may be scarce.
What performance outcomes and benchmarks have been achieved by the CARP framework in comparison to traditional methods? And how does it demonstrate its capabilities in low-resource and domain adaptation settings?
The CARP framework has achieved impressive performance outcomes on various widely used text classification benchmarks, showcasing its effectiveness compared to traditional methods. Here's a breakdown of its achievements. 1. State-of-the-art, SOTA, performances. CARP has set new performance records on 4 out of 5 key benchmarks. SST2, 97.39, which is an improvement of 1.24 over previous methods. AGNEWS, 96.4, with an increase of 0.72. Rate, 98.78, showing a boost of 0.25 dartaral. R52, 96.95, up by 0.6. Mr. achieved a performance of 92.39, which is very close to the best score of 93.3. 2. Low resource settings. One of the standout features of CARP is its ability to perform well in low resource and domain adaptation scenarios. When tested with only 16 examples per class, CARP demonstrated performance comparable to models that required over 1,000 examples per class. Specifically, in low-resource setups, even with just 16 examples, the accuracy of CARP on the SST2 dataset was around 90%, while traditional supervised models struggled and performed similarly to random guessing. 3. Generalization ability. This remarkable performance in low-resource situations illustrates CARP's strong generalization skills. It can make accurate classifications even when it has limited training data, which is a significant advantage in real-world applications where labeled data may be scarce. Overall, CARP not only outperforms conventional methods, but also shows that it can adapt and excel even when there is minimal training data available, making it a valuable tool for text classification tasks in various contexts.
What implications do the findings and advancements of the CARP framework have for future research and applications in text classification, particularly in terms of addressing the limitations of large language models?
The findings and advancements of the CARP framework have significant implications for future research and applications in text classification, particularly in overcoming some limitations of large language models, LLMs. Here are the key implications. 1. Enhanced reasoning capabilities. CARP addresses the lack of reasoning ability in LLMs when faced with complex linguistic phenomena. This opens up new avenues for research focused on improving models' capability to understand subtleties in language, such as sarcasm, intensification, and contrasts. Future studies could build on CARP's techniques to develop even more sophisticated reasoning strategies. 2. Low-resource adaptability. The framework's success in low-resource settings, where it performs well, even with a minimal number of examples, suggests that future research could explore methods to make LMS more effective in situations where training data is scarce. This is particularly valuable for applications in specialized fields or languages with limited available data. 3. Integration of fine-tuning techniques. By utilizing a fine-tuned model for demonstration search, CARP highlights the importance of incorporating specific training data, tailored to the task at hand. Future research can focus on developing better fine-tuning methods that enhance the adaptability of LMS across various domains. 4. Potential for generalization. The ability of CARP to generalize well from limited examples indicates that this method can be applied to various text classification tasks, increasing its utility in real-world applications. Researchers can investigate how this generalization ability can be leveraged in other natural language processing tasks beyond classification. 5. Framework for future models. The CARP approach provides a structured framework that future models can adopt by systematically identifying clues and employing a reasoning process. New models can be developed that combine the strengths of both traditional fine-tuning and contemporary LLM technique. 6. Real-world applications. The performance of CARP in practical scenarios, such as domain adaptation and low-resource conditions, suggests that businesses and organizations can adopt this framework for more effective text classification systems, particularly in industries where data availability is limited. In summary, CARP not only enhances current text classification methods, but also sets a foundation for future advancements in LMS, pushing the boundaries of what these models can achieve in understanding and processing language accurately, even when resources are constrained.
Thank you for sharing such valuable insights about the CARP framework and its implications. How does CARP pave the way for exploring interdisciplinary applications? And what fields could particularly benefit from its capabilities in text classification?
The CARP framework paves the way for exploring interdisciplinary applications by providing a robust method for text classification that can adapt to various fields and contexts. Here are some areas that could particularly benefit from its capabilities. 1. Healthcare. In healthcare, CARP can be used to classify patient feedback, research studies, or clinical notes. The framework's ability to handle complex linguistic phenomena can help in accurately interpreting medical jargon, sentiments, and critical information within patient records or feedback. 2. Social sciences. Fields like sociology and psychology often deal with nuanced language and sentiments in survey responses or interview transcripts. CARP's reasoning capabilities can help researchers analyze complex emotional responses or identify underlying themes in qualitative data. 3. Legal studies. The legal field frequently involves interpreting intricate language in documents, contracts, and court rulings. CARP can assist in classifying legal texts and identifying significant phrases or sentiments that may influence legal outcomes. 4. Marketing and sentiment analysis. Businesses can leverage CARP to analyze customer reviews, social media comments, and marketing content. The framework's advanced reasoning can help in understanding customer sentiments and preferences, enabling more effective marketing strategies. 5.2. Education. In educational settings, CARP can be applied to analyze student feedback, essays, or discussion transcripts. It can help educators gauge student sentiments and the effectiveness of teaching methods, providing insights for improvement. 6. Finance. The finance industry often requires sentiment analysis of news studies, and social media to gauge market trends. CARP could enhance the accuracy of these analyses, helping investors make informed decisions based on public sentiment. 7. Natural language processing and AI development. Researchers in AI and NLP can build upon CARP to develop new models that further integrate reasoning and contextual understanding, leading to advancements in machine learning and artificial intelligence applications. Overall, CARP's ability to handle complex linguistic features and perform well in low-resource settings makes it a versatile tool that can be adapted across various disciplines, improving the accuracy and effectiveness of text classification tasks in diverse fields.
Thank you for highlighting the interdisciplinary potential of the CARP framework. To conclude our discussion, could you summarize the key takeaways from the study regarding how CARP addresses the limitations of large language models in text classification and its overall significance in advancing the field?
The key takeaways regarding how the CARP framework addresses the limitations of large language models, LLMs, in text classification and its overall significance in advancing the field are as follows. 1. Addressing reasoning limitations. CARP introduces a progressive reasoning strategy that helps LMS tackle complex linguistic phenomena, such as irony, contrast, and intensification. By guiding the models to first identify superficial clues and then engage in a diagnostic reasoning process, CARP enhances the reasoning capabilities of LMNs, which is crucial for accurate text classification. 2. Effective handling of limited token context. To overcome the challenge of limited tokens in in-context learning, CARP employs a fine-tuned model for NINN demonstration search. This allows the LLMs to leverage task-specific evidence while maintaining their generalization abilities, effectively connecting them to a broader training dataset, despite the constraints. 3. State-of-the-art performance. CARP has demonstrated significant performance improvements, setting new state-of-the-art results on 4 out of 5 widely used text classification benchmark, with scores of 97.39 on SST2, 96.4 on AgNews, 98.78 on RATE, and 96.95 on R52. CARP showcases its effectiveness and reliability in various classification tasks. 4. Strength in low-resource environments. One of the standout features of CARP is its ability to perform well in low-resource settings. It achieves comparable performance to supervised models, even with a mere 16 examples per class, indicating its robustness and adaptability in real-world applications, where data may be limited. 5. Significance for the future of text classification. The advancements made by CARP highlight its significance in pushing the boundaries of what LMS can achieve in text classification. It sets a foundation for further research into improving reasoning in language models and opens doors for interdisciplinary applications across various fields. In summary, the CARP framework not only addresses critical limitations of LMS, but also propels the field of text classification forward, enhancing model performance and applicability in diverse contexts, especially where resources are limited.
Thank you for joining us today. We've explored the CARP framework, which transforms text classification by overcoming LLM limitation. CARP's 3-step reasoning process enhances LM's reasoning capabilities. It integrates a fine-tuned in-and demonstration search model, combining task-specific knowledge with generalization abilities. CARP surpasses traditional methods, setting new benchmarks. It excels in low-resource scenarios, generalizes well, and sparks new interdisciplinary applications. CARP's advancements pave the way for future research and sophisticated LLMs for precision text classification. Thank you for engaging in this discussion.